Welcome to the next lecture of Mechanics of Material. This is Salman, Assistant Professor of Mechanical Department, ISL College of Engineering. Today we are going to discuss our next topic in Mechanics of Material. Last class we have discussed about the how the stresses are going to behave if there are various number of forces. For example, we have discussed about principle of superposition. If a bar section is having various number of forces, how we have to identify the overall deformation. Now we are going to discuss the relationship between the elastic constants, the relationship between various elastic constants. So already we have discussed a few of them, that is modulus of elasticity. This is nothing but if the body is within the elastic limit, the stress and strain are directly proportional. That constant is nothing but modulus of elasticity. And now what is modulus of rigidity is nothing but once the material crosses the elastic limit, enters into a plastic region, this rigidity will come into picture. Similarly, the bulk modulus is nothing but it comes under a volumetric strain or modulus of volumetric. Okay, bulk modulus. We have discussed all these things. So now we are trying to find the relationship between the modulus of elasticity, which is denoted as E, and bulk modulus, which is denoted as K. So first of all, let us see that the strain we have taken, there is nothing but delta L by L. We already know this, but what we have to see is the first thing before we identify the relationship between E and K, we have to identify what is Poisson's ratio. So why we discuss about Poisson's ratio is nothing but once you are having a deformation along the length, so obviously with respect to the effect on uh, longitudinal variation, obviously there will be a variation along the diameter. Obviously there will be, for example, you take a rubber band, you try to stretch it. So once the length of the rubber band increases, obviously the thickness or the diameter of the rubber band tries to decrease. So that how much amount it is decreasing, that much it will be trying to extend. This property is nothing but Poisson's ratio. So generally the Poisson's ratio is defined as the ratio of lateral strain to longitudinal strain. Lateral strain to longitudinal strain. It is denoted as mu, or even it is denoted as 1 by m. I have not written here. Please try to note if it is denoted by mu or 1 by m, where mu is equal to lateral strain by longitudinal strain. So first of all, you have to understand what is lateral strain. So I have drawn an example here. So lateral strain is the change in the dimension either in breadth, height, diameter with respect to original dimensions. For example, you take the section, so which is having a length L1 and B1. Now I am applying a tensile force on this. As I apply the tensile force, it tries to expand. It tries to expand. When it is expanding, from where this extra material is coming is nothing but it is coming from the extra breadth. So the breadth, what is happening here, the breadth is going to decrease and length is going to increase. So this ratio, which by what the decrease in breadth is happening, that is nothing but called as lateral strain, whereas this increase which is happening in length is called as longitudinal strain. So generally the lateral strain is nothing but either it may be delta V by V or delta H by H or delta D by D. Because of this breadth, height or diameter, there will be increase in the value of your length, that is nothing but longitudinal strain. So what is the value of this Poisson's ratio for mild steel, or steel is in the ratio of in the range of 0.23 to 0.32, and the maximum value of this Poisson's ratio is 0.5. Maximum value of this is 0.5, and that maximum value is obtained for rubber. So the Poisson's ratio, we can write it as delta V by B or delta L by L or delta H by H or delta L by L. So you can, instead of delta B by B, you can even use delta H by H, or you can use delta D by D, basing upon the type of problem and basing upon the type of application. So we'll keep on seeing this. So now when I say volumetric strain, so as I have shown you the first diagram, now what I'm doing is, first I'm taking a cubic structure on which I'm adding three sections, which is having x-axis, y-axis and z-axis. Initially I'm applying a force along x-axis. Because of this what we say axial force along the x direction, because of the axial force along the x direction, how the stress is going to be obtained, that we are going to see. What are the volumetric changes that are going to obtain in x and y and z direction, that we are going to see. So first of all, let us see EV is equal to Ex. That is nothing but when I apply the stress in X direction and apply the axial load in X direction, because of that there will be change in X, there will be change in Y, there will be change in, obviously if the load is applied along the X direction, the X will increase, Y will decrease, and Z will also be decreased. Consider a sponge. You are trying to pull the sponge from one direction, that is along the X direction. What happens to Y direction? It will reduce. What happens to Z direction? It will reduce. So both the reductions will be able to give in X direction. So we know that according to Poisson's ratio, we can draw the relationship between x and y. That is, Ey by Ex is equal to mu, Ez by Ex is equal to mu. Why we are converting only with respect to x is since the load is applied along the x direction. So this y which is happening in the strain with respect to x, that is nothing but Poisson's ratio. Because of this y only there is a strain in x direction. Similarly, because of z only there is strain in x direction. So in the place of Ey and Ez, we can write mu Ex and mu Ex with respect to Ez. And now we can rewrite the whole equation. Ev is equal to Ex minus mu Ex minus E mu x in the place of Ez. Why this minus is coming is nothing but because of increase in the length along the x direction, there will be decrease in y and z. That is I have written minus sign is because it decreases when the length is going to increase. When the length is going to increase, they are going to decrease. Because of that, we are changing the sign to minus. Now if you take that EVX, that is nothing but E with respect volumetric strain with respect to x axis direction force, we are going to apply Ex is equal to 1 minus 2 mu. Here we have applied when the load is applied in x direction. Similarly, when the load is applied in y direction, we can able to get Ey of 1 minus 2 mu. Same thing will happen here. We again going to get Ex, Ey, Ez. Because the extension is happening in y direction, there will be change in z and x. So that we can able to obtain again like this, Ey of 1 minus 2 mu. Similarly, in z direction, Ez of 1 minus 2z. Now overall volumetric strain because of all the forces is nothing but Ev is equal to Evx plus Eyv plus Evz. Now we add all this. In this we are going to get 1 minus 2 mu common. So if you take this 1 minus 2 mu common, you are going to get that. Sorry, there is again this page has been repeated. So 1 minus 2 mu, that is Ex plus Ey plus Ez. 1 minus 2 mu of Ex plus Ey plus Ez. If you take this, if all the strains which are going to increase because if the load is same, the strain is going to obtain equal in all the direction. Now I am considering that I am applying the load along all the directions, equal forces. If the forces is equal, since the material is same, the strain will also be same. Now Ex is equal to Ey is equal to Ez is equal to E. Therefore, Ev is equal to 3E because 1, 2, 3. E plus E plus E. 3E of 1 minus mu. Now, already we know that when we have volumetric strain, we have previously studied that stress by bulk modulus, that is sigma by K. Similarly, the linear strain, because here if you see either in x direction or in y direction or in z direction, the strain is going to happen linearly. That is nothing but stress is equal to modulus of elasticity, that is sigma by E. Sigma by E. Now if you replace all this in the equation this, so in the place of Ev we can write sigma by K, in the place of E we can write sigma by E. See here also sigma, here also sigma, both will be cancelled. Then we will going to obtain the equation like 1 by K is equal to 3 of 1 by E into 1 minus 2 mu. 1 by K is equal to 3 of 1 by E into 1 minus 2 mu. Just simply you cross multiply. This E goes on the upside and this K comes on here. So E is equal to 3K of 1 minus 2 mu. This we consider as equation 1, where we have identified the relationship between Young's modulus or modulus of elasticity and bulk modulus. Modulus of elasticity and bulk modulus. Now we are going to obtain the relationship between a modulus of elasticity and modulus of rigidity. So when I say modulus of rigidity, this will come into picture when there is a force, when the force is acting parallel to the surface, that is nothing but shear force is coming into picture. So we know that shear force or the strain which is obtaining with respect to shear stress or bulk modulus of rigidity, G is equal to shear stress by shear strain. Bulk modulus or modulus of rigidity is equal to shear stress by shear strain, shear stress by shear strain. So shear stress is denoted by sigma, sorry, shear stress is denoted by tau. Generally what sigma indicates the normal stress, sigma indicates the normal stress, tau is shear stress by shear strain, shear stress. Now shear stress we already discussed, shear strain is nothing but the variation with respect to which is happening along phi. How this is coming into picture is nothing but, consider this block, we are applying the parallel force here. Because of this parallel force, what happens to this R and S section, it will try to extend forward, it will try to extend in the forward direction. I will try to draw the another let us see this. So this will also be extended till here. So this is my S dash, this is my S dash, this is my R dash, this is my nothing but this RS has been moved forward to an angle of phi. So generally what we say, strain is nothing but change in dimension by original dimension. What is the change here happening? So initially it is from R to S, now the length has been increased to S R dash, S R dash. So this is my L2 minus L1 is S R1 minus S R, that is nothing but R1 divided by R1 divided by S R1 divided by S R1 divided by S R, that you can able to find. Okay. Similarly, once you know that this is phi, you can able to find that the relationship between this axis and this value, that is nothing but by taking the tan phi. We know that tan phi is equal to opposite by adjacent. To this, what is opposite? R dash, and what is adjacent? This is QR. This is QR. If phi is small, generally we can consider tan phi is equal to phi. If phi is small, we can consider tan phi is equal to phi. Now shear stress tau by phi is equal to G, tau by G is equal to phi, that is nothing but modulus of rigidity. We can able to take this G as a modulus of rigidity, phi is strain. Now this is the generalized formula for strain. But however, here when you see this kind of problem, in this the strain is happening along the diagonal. Strain is happening along the diagonal. That this is my diagonal PR. Initially the diagonal was like PR, now it is PR dash or PR1. So which we are going to identify that how the shear stress is going to happen. Already you have written that tau by G is equal to phi, and phi we have taken here as, see here, tan phi. So here we have taken tan phi. Okay, so in the place of tan phi we can write phi, that is nothing but R dash by Q. Okay, so we can take it right. I will write here again, phi is equal to R dash by QR, R dash by QR. Clear? So that I am replacing in this equation. Therefore tau by G is equal to R dash QR. Now take this diagonal from the triangle RTR. So we are taking this diagonal. Now according to this diagonal, what is the change? Before coming into this, let us go to straightly go to this. According to this diagonal change, so what is the strain that we are going to observe is nothing but initially the what is the change happening in the diagonal is nothing but, if you see here, initially the diagonal is PR. Now the PR has been changed to PR dash. So if you draw an exact perpendicular from here, that PR and PT will be always equal. Correct? I am writing here PR will be equal to PT. PR will be equal to PT because they are of same length. Okay. Now what is the change extra which I am going to get after deformation is TR dash, correct? So the strain will be like TR dash divided by original. What is original? PTR PR. Here see that PTR PR, PTR PR. Change the now the strain along the diagonal is equal to TR dash by PT, TR dash by PT. So the very first thing I have to identify is TR. So for identifying the TR, let us go into the small triangle, this TRR dash, this triangle TRR dash, this TRR dash, this is R dash, don't get confused, I have drawn here TRR dash. So according to this triangle, when I do this is 45, obviously this is 45. Since this is perpendicular, this is again 45. I have drawn in the previous picture, you can see this clearly. I have marked with red ink. So this is 45 means this is 45. Once this is 45, this will be always 45, correct? So this is 45 means obviously since this is perpendicular, again this is 45. Okay. So once this is 45, you can take this as 45. Clear? So according to that, we have drawn those things and we have identified those to be 90 degrees. Okay. Clear? So according to this is 45 degrees. So TR dash is equal to TR dash. This is my TR dash. This I want to find, because why I am going to find? Because I have the value phi is equal to TR dash by PT. How we are going to obtain that? Because the diagonal initially was PR. Now the diagonal has changed to PR dash. So what is the change that we are going to increase, which we are going to obtain is TR dash has been obtained extra. So TR dash by original, that is nothing but PRR PT. So I have to find this from this triangle, this TR dash. Okay, TR dash that I am going to obtain, that is look at this, this is 45, this is 45. So this is my I want to identify this length. So this is my adjacent side to TR. If I take the TR is equal to RR dash. Why I am taking RR dash is nothing but I want in terms of RR dash. RR dash cos 45. TR dash can be written as RR dash cos 45. You take that. So generally what is cos 45? Adjacent by hypotenuse. What is adjacent here? This is your adjacent. TR dash is your adjacent. So this is your hypotenuse. This is your hypotenuse. So the TR dash is equal to RR dash by cos 45. Similarly, another thing which you have to identify is PET. Another thing which you have to identify is PET. But in the place of PT, we can take it as PR also. We can take it as PR also, correct? Why means we have written here PT and PR are equal. So I want to identify the value of PR. So where I can identify the value of PR is nothing but from the triangle PQR. So I am taking the triangle PQR. So once I take PT is equal to PR is equal to, I look at this triangle. I want the value of PT, that is nothing but this PR. I want the value of this PR. Now I have the value of QR. So what is how we are going to take is consider cos theta. What is cos theta? Adjacent by hypotenuse. Adjacent by hypotenuse. So what is adjacent here? QR is my adjacent. QR is my adjacent. What is my hypotenuse? PR is my hypotenuse. So cos 45 is equal to TR dash. Similarly here I can write cos 45 is equal to, or PR is equal to QR by cos 45. You take that cos 45 other side, QR by PR you can get. From that PR is equal to QR by cos 45. Substitute both the values here, you are going to get RR dash cos 45 by, or here you can either take sin 45 or cos 45, both will be having same value here. So no problem, QR by cos 45. RR dash is equal to RR sin 45 into cos 45. That is sin 45 value is 1 by 2, cos 45 value is 1 by 2. RR dash by QR, that is nothing but RR dash by QR into 1 by root 2 into 1 by root 2 is 2. That is RR dash by QR. See this, remember this RR dash by QR, you have got the same value here. RR dash by QR, you have got the same value here, that is nothing but tau by G. In the place of here we can write tau by G. In the place of here we can write tau by G. So the strain along the length is along the diagonal is going to be get tau is equal to tau by 2G. Why this 2G extra is coming is nothing but because there is a along the diagonal, if one diagonal is going to get the strain tensile force, other diagonal is going to get the compression force. Which is going to get tension is nothing but this. Okay, so how we are considering this is going to be tension? Because initially the length of this was like this. Now the tension, because of application of tension, the length of this is going to be increased. Similarly, this QS, I am drawing this here. See this. Initially the diagonal was from Q to Initially the diagonal was from Q to S. So now the value has been reduced. So this is a compression. So here I have written clearly. Please have a look here, because PR undergoes tension and QS undergoes the compression. PR undergoes the tension, whereas QS undergoes the compression. Similarly, when it is going to undergo compression, we know that if it is a tensile force, what is the strain according to tensile force? If it is only linear we are going to take, then it is going to be sigma by E. Because of this linear, obviously this increase is happening, means there is some decrease happening in QS. Why, sir, you are saying that? Because if one side is increasing, means that increase is happening because of reduction and other thing. Already we have seen this in Poisson ratio. If one side it is increasing, means from the other side it is going to be decreased. That is Q by sigma by E is equal to mu by E, that is nothing but which occurs in QS. The total strain is equal to sigma by E plus mu by sigma by E. Generally we can use minus also here, but no need. Here we are going to add, because it is happening along the diagonals. So 1 plus mu of sigma by E, 1 plus mu of sigma by V. So this total strain and this strain which is happening along the diagonal should be equal. That is tau by 2g is equal to sigma by E of 1 plus mu, sigma by mu of 1 by mu. But the effect of tau and the sigma are almost equal. That was, there is the effect of sigma and tau are almost equal. So we can cancel out. We can write it as E is equal to 2g of 1 plus mu. So we have got the equation 2, in which we are having a relationship between E and G, and previously we have a relationship between E and K. Okay. So according to the first equation, E is equal to Ek of 1 minus 2 mu. According to second equation, is equal to E is equal to 1 plus 2g plus 2g of 1 plus mu. So both are equal. So we can compare both the things, and we can have to find the relationship between E and G without Poisson's ratio. So without Poisson's ratio, if you want to find the relationship between E, K and C only, E, K, C or E, K, G, G and C are equal, don't get confused. Some authors use C, some authors use G. You can use both. So now what I am trying to do is, first I will take this two and find the value of mu. I will take these two equation, these two values, and find the value of mu. So let us see how we are going to solve this. So since this is in multiplication, it comes on the other side, it will become division. That is equal to 1 minus 2 mu. Now 2 mu will become this, 2 mu goes on this side. Clear? So this becomes plus, and this will come on this side. So this will become minus. So 2 mu is equal to 1 minus E by K. 1 minus E by K. 1 minus E by K. So mu is equal to 1 by 2 of 1 minus E by 3K. Okay. Now similarly equation 2. Equation 2 is nothing but this, 2g of 1 plus mu. From this again we have to identify the value of mu, that is E by 2g of 1 plus mu. This mu remains on the same side. I will send this one on the other side. So mu is equal to E by 2g minus 1, E by 2g minus 1, E by 2g minus 1. Now this is equation 3, this is equation 4. But see here, this is also mu, this is also mu. If these two are equal, obviously these two should be equal. If left sides are equal, right side should be equal. So I am equating this to 1 by 2 of 1 minus E by 3K is equal to 3 by 2g of 3 by 2g minus 1. So what I am trying to do is I am multiplying this 1 by 2 here. 1 by 2 into 1, 1 by 2. 1 by 2, 1 by 2 minus 3 by 3K, 1 into E1, 2 into 3K, 6K, correct? So I am going to get is equal to E by 2G minus 1. So what I am trying to take, I am trying to take all the E values one side, all the constants one side. Constants are nothing but the numerical values. So this minus, it will go on this side, it will become positive. This minus 1 goes on this side, and this will become positive. So this I am taking on this side. So E by 2g plus E by 6g. E by 2g plus E by 6g. 1 by 2 plus 1. 1 by 2 plus 1. Now here see this, both the E are common. So I am trying to common out. So what is left out? 1 by 2g plus 1 by 6. I will write here if you are getting confused here. E is common out here. So I am keeping it as 1 by 1 divided by 2g, 1 divided by 2g plus 1 divided by 6k, 1 divided by 6k. This will be left out once you are taking out the common of, okay, once you are taking out the common of E. So once I am taking out the common, what I am trying to do is I am trying to solve this equation by doing cross multiplication. That is, I will do cross multiplication of these two and I will multiply. What is cross multiplication? We are going to get like this: 6k plus 2g divided by multiply these two. So what is the multiplication? This is nothing but LCM of two different variables. So if two different variables are there, you can take out the LCM by doing cross multiplication and multiplication of the denominators. 6k plus 2g by 12gk, that is equal to, here similarly, you are again taking the two different LCM, two different denominators are there. You are taking out the LCM, 2 into 1, 1 will go this side, 2 will come this side, 2 plus 1, 3, 3 by 2. Okay, so I want the value of E is equal to 12 into 3 into gk, cross multiplication, this will go above. So this will go 2 and 3 into 12 gk divided by 2, this numerator will come denominator, 6k plus 2g. So 2 ones are 2, 2 6 are 12. Now here it is 3 6 are 18 gk divided by 6k plus 6g plus, sorry, 6k plus 2g. Again, if you see here in these both, in the denominator, what is common? 2 is common. What is common? 2 is common. So 2 I am taking out common. So this will be like 3k plus g. 3k plus g. 2 is common. So this 2 and this 18 will get cancelled. 2 ones are 2. 2 nines are 18. So gk by 3k plus g. E is equal to 9gk plus 3k plus g. This is very important problem. Repeatedly this problem has been asked in many number of question papers. So try to go through this question again and again. If you have any doubts, please